A very warm good afternoon to everyone. Now today we will solve internal 2 paper. So the first question reads in Bayes theorem probability of A by B is equal to. We know that the formula for probability of A by B is equal to probability of B by A into probability of A divided by probability of B. So this is the general formula of Bayes theorem. Now second question is 68, 95, 99.7 rule describe the probability mass of the normal distribution that is Gaussian distribution. This rule refers to the empirical formula for normal distribution. Now the third question is the metric that measures uncertainty gain when replacing distribution A with B is called. Obviously, it is Kaggle divergence because we know that Kaggle divergence measures how one probability distribution diverges from the another. Now, the fourth question is ridge regression uses a L2 penalty while LSO uses an L1 property. We know that ridge means L2 regularization and LSO means L1 regularization. Now, moving to fifth question, a model that performs well on training data but fails on unseen data suffers from overfitting. We know that this is what overfitting means. A model that performs well on training data but fails on unseen data. It suffers from overfitting. Now, the sixth question is in logistic regression, coefficients are estimated using the maximum likelihood function. The reason behind it is very simple that logistic regression estimate parameters by maximizing the likelihood. The seventh question is the hyperplane in SVM that maximizes distance between classes is called the maximum margin hyperplane because the SVM decision boundary is the maximum margin hyperplane. In eighth question, it is read as in clustering, K means minimize the within cluster sum of square of distance. The reason is very simple that K means minimize within cluster sum of square distance. And in ninth, in PCA, the first principal component capture the maximum possible data variance. The reason is very simple that PCA first component capture the maximum variance. Now 10th, CNN are particularly effective for image data while RNN is suited for sequential data. We know that CNN work with image data and RNN is work for sequential data. In TensorFlow, the structure representing operations and dependence is called a computational graph. The reason is very simple. TensorFlow construct a computation graph before execution. Now, 12 question read as Hadoop fault tolerant distributed storage system is called SDFS. SDFS is stand for Hadoop distributed file system, manage distributed data across nodes with redundancy. SQL query combining rows from multiple tables based on related column use the join clause. In SQL, join is the clause through which we combine multiple rows from multiple data. A Python collection that insert only unique element is called a set because we know that set only allowed the unique elements. Bootstrapping is a resampling method that samples with replacement. The reason is that bootstrap sample with replacement to create a pseudo replicates. Now moving to the section B, which is match the following questions. Now Manhattan distance, we know that Manhattan distance here k is equal to 1, so sum of absolute difference. Euclidean distance being k equal to 2 straight line distance. Pearson coefficient uses covariance. So here is the option. It uses uh, covariance normalized by standard deviation. Fifth one is L1 regularization. So it sinks some coefficient to 0. Sixth is L2 regularization, shrink all coefficient proportionally. Seventh is bagging. Use bootstrap aggregation of trees. It uses now eighth one is boosting. So sequentially focuses on misclassified samples. Ridge regression uses penalty. Penalize larger coefficient via. Lesser regularization uses penalty lambda sum. Now moving to the section C, which is based on deep learning. Compute probability of fair die roll twice. Probability that sum 7 will be 6 divided by 36, that is 1 by 6. Because 6 variable outcomes, that is 1 by 6, 2, 5, 6, 1 will give you 1 by 6 probability. For a binomial distribution n equal to 2, p equal to 0.5, expected value will be 10 into 0.5, that is 5. Because for binomial distribution n comma p mean is equal to np. If r square equal to 0.8 and tss equal to 100, compute rss. Rss will be 20 because we know that rs is equal to ss into 1 minus r square into 1 minus r square, that is 100 into 0.2 equal to 20. In linear regression, gradient descent and update rule for weight w equal to w minus alpha x will be alpha j upon my alpha w. Now moving to the question 20. For a normal 0, 1 distribution, what percentage of data lies between -2 and +2? It will be 95.4. For plus minus 2 sigma in normal 0, 1, it will be around 95.4 approximate of data lies within. For k-fold cross validation with k equal to 5, each iteration uses what percentage of data for training? It will be 80 percentage, because precision is equal to uh, it will be, because in k fold each fold uses 4 by 5 of for training and 1 by 4 1 by 5 for validation. We have to calculate precision. If TP equal to 40, FP equal to 10, then what will be the precision? We know the formula for precision is TP upon my TP plus FP. So it will be 40 upon my 40 plus 10, which will give you 0.8. Now moving to 23rd question is, if recall equal to 0.8 and precision equal to 0.1, F1 score what will be? It will be 0.533. A model given TP equal to 70, TN equal to 80, FP equal to 20, FN equal to 30. So accuracy will be 0.75. We know the formula for accuracy, it is TP plus TN upon TP plus TN plus FP plus FN. So it will be 0.7. What will be the expected value if the lambda is 3 for Poisson distribution? So expected value will be around mean equal to variance. So here it will be 3. Mm, Now moving to the section D, where we start with the 26th question. Write Python code to compute mean if list A equal with now. We know that there is inbuilt function with the name mean, so we just write np dot mean a. This is a numpy library we use for mean, and we had to, in question number 27 we had to convert the list to numpy array. For that we write np dot array 1 2 3. Now we have to create a data frame from a dictionary. We know that dictionary means key value pair. Using patterns, we can convert it. We have inbuilt method for that, pd.data frame, and pass the dictionary values. 29 question that replace all missing value in data frame df with column mean. For that we have filna method, df.filna df.mean comma in place equal to true. 30th question, display first 5 rows of data frame. So for that we have head will fetch the first 5 elements. Now we have to plot a histogram. We know for that we have matplotlib library of a height. So we just use the hist function which draw the histogram. So we write plt.hist df of height. Now 32 question which read as apply one hot encoding to categorical column color. For that we write pd.get dummies df color. 33 question, compute correlation between two pandas columns x and y. For that we have a function cor. So we write df of x dot cor df of y. Find unique elements in a list using a Python set. We know that Python set stores only unique elements, and we have to find from a list a unique element. So we just pass that list into the set function, set of a. 35th question, add a new key value pair in pi, that is pi 3.14 to a dictionary. So we just write the pi in subscript operator, which is 3.14 in the key value pair. Create a DQ and append elements 1 to 3. First we have to create a DQ and then append 1 to 3. So for that we write DQ equal to DQ 1 to 3. Now 37 question which read as pop smallest element from heap. Smallest elements, so for that we have heap pop function. So we will write it as heapq dot heap pop heap. 38 question, create numpy array of zeros of shape 3 comma 3. So for that we write np dot zeros 3 comma 3. Now convert column date to determine type in panda. For that we write pd dot to date time df date. Filter data frame rows where column score is greater than 50. For that we write df of score greater than 50. Now moving to the section E, uh, 41 question which read as no single ML algorithm perform best on all problems refers to bias variance trade-off. It is a theorem which read as no single ML algorithm perform best on all problems refers to the bias variance trade-off. It says that just balance simplicity, bias, and flexibility variance. 42 question, the method that uses smallest training subset repeatedly to estimate test error is called no free lunch theorem. It is a philosophy which said that no single algorithm works best universally. 43rd question, in KNN runtime growth with big O of cross n, cross validation, where n is the number of points and d is the dimension. Because repeatedly estimates model error on held out sets. 44 question, the curse of dimensionality affects algorithm that depends on big O of nd, because high dimensional distances lose meaning curse of dimensionality. 45th question read as PCA transform correlated features into distance components. High because PCA construct orthogonal principal components. Hope you understand all the question. If you have queries, please write down in the comment section. We will contact you soon and try to reply your comments as soon as possible.